logarithmic function. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. Consider the following exponential function f of x equals 2 to the power of x. Let's complete the table of values for the function f, and using this table of values, we can sketch a graph of the function f. Now let's find the equation of the inverse function. Since f is defined by y equals 2 to the power of x, to obtain the inverse function, we switch x and y. The inverse function of f will take all the x and y values and switch them. So we can complete the table of values for the inverse function of f, and we can sketch a graph of the inverse function. The inverse function of f is called the logarithmic function with base 2, and we write in this form. We can read as y equals the logarithm in base 2 of x, or y equals logarithm with base 2 of x, or y is the logarithm of y to the base 2. Anyway, logarithms are defined to be the inverse of exponentials. We can write, if y is b to the power of x, then x is the logarithm of y to the base b. X is the exponent to which the base b is raised in order to get y. The main features of logarithm function. The logarithmic function is the function. And never forget, logarithms are exponents. They are just written differently. The relationship y equals the logarithm in base b of x means the same thing as b to the power of y equals x. Therefore, like exponential functions, logarithmic functions must have a positive base and different from 1. Now let's try to evaluate the logarithm in base b of minus 4. What power y could possibly turn a positive base b into a negative 4? This just is not possible. Therefore, we cannot evaluate the logarithm of a negative number. Now let's try to evaluate the logarithm in base b of 0. What power y could possibly turn a positive base into a 0? This just is not possible. Therefore, we cannot evaluate the logarithm of 0. Now, let's try to evaluate the logarithm in base b of 1. What power y could possibly turn a positive base into a 1? This is possible as long as y is always 0. Therefore, the logarithm of 1 in any base is 0. In short, we can write it all down like this. Let's graph the function y equals log base 2 of x. The logarithmic function is the inverse of the exponential function. So we take the same table of values as the exponential function and switch x and y to make a table of values for the logarithmic function. We plot these points and connect them with a smooth curve. The logarithm graph passes through the point 1 and 0 and then continues down along the right-hand side of the y-axis. Notice that this graph is very close to the y-axis but does not cross it. So the y-axis is the asymptote of the graph. The x values of this graph are always positive, and the y values increase as the graph progresses to the right. Now let's graph the function y equals log base 1/2 of x. The inverse of an exponential function is a logarithmic function. Remember that the inverse of a function is obtained by switching the x and y coordinates. So we take the table of values for the exponential function y equals 1/2 raised to the power of x and switch x and y to get the table of values for the logarithmic function y equals log base 1/2 of x. We plot these points and connect them with a smooth curve. This graph is very similar to the log base 2 of x, but now the y values decrease as the graph progresses to the right. You must notice that the graph of y equals log base b of x is asymptotic to the y-axis. If base is greater than 1, the graph increases. If the base is between 0 and 1, the graph decreases. The domain is all positive real numbers. The range is all real numbers. The graph crosses the x-axis at the order pair. Shifting graphs of logarithmic functions. In general, the logarithmic function can be written as y equals log base b of x minus h plus k. H controls horizontal translation and k controls vertical translation. The equation of the vertical asymptote is x equals 8. Let's graph the function y equals log base 2 of x minus 3 plus 2. The graph of this function is obtained from the graph of log base 2 of x. The equation of the asymptote is x equals 3. We have to shift the graph 3 units to the right. K equals 2. So we have to shift the graph 2 units upwards. Now let's graph the function y equals log base 1/2 of x plus 2 minus 1. The graph of this function is obtained from the graph of log base 2 of x. The equation of the asymptote is x equals minus 2. So we have to shift the graph 2 units to the left. K equals minus 1. We have to shift the graph 1 unit downward.